This is the bubble sort algorithm. Bubble sort is a simple sorting algorithm which repeatedly iterates through a list of unsorted integers, comparing each integer to its neighbor. If the two being compared are found to be in the wrong order, they swap positions. The process repeats until no more swaps are needed, indicating that the list has been correctly sorted. Let's visualize exactly how this algorithm works. Let's say we have the following list of integers: 6, 5, 7, 4, and 9. First, we put our bubble around the first two elements that are in our list and compare their values against one another. Since 6 is greater than 5, the two numbers get swapped. Now we move on to the next adjacent pair. We can see that 6 is lesser than 7. Therefore, we do not need to swap the numbers, so we can move on to the next adjacent pair, which is 7 and 4. Since 4 is less than 7, we swap them and continue. Last, we see that 7 is less than 9, so we leave them as is. We have officially completed our first cycle through the list, and the highest number found has now bubbled to the top of our list. But we can see that the list is not completely sorted yet, as 4 is the lowest number, but it's still in the middle. This is when we would do a second cycle through our list up until the sorted number, which is 9. 5 is less than 6, so we leave them as they are. 6 is greater than 4, so we swap their positions. 6 is less than 7, so we leave that, and now we know 7 is officially sorted properly. Third cycle. 5 is greater than 4, so we swap them. Iterating through the rest of the list, we can see that everything is now sorted and nothing will be swapped. So the algorithm will now end. If the list wasn't sorted after the third cycle, the algorithm would have continued to complete as many cycles as required until the list was sorted correctly. Here's a layout of the algorithm and pseudocode for the bubble sort algorithm, so you can try it for yourself in your favorite programming language. First, let's start by creating a function that takes an unsorted array of integers as an input. We next create a variable, let's say n, which is the length of our unsorted list. We'll also set a variable equal to false for now, which we'll use to check that some sort of swapping or sorting has occurred when we iterate through our list. Next, we create a loop which repeats the following procedure until our list is completely sorted. First, iterate through all unsorted integers in our list, comparing adjacent integers. Second, for any unsorted adjacent integers, swap their positions. Third, if no swaps have occurred throughout the entire loop cycle, break the loop. Once the loop breaks, we know our list has been completely sorted, so we can return the sorted array. You can use this pseudocode to run a bubble sorting algorithm in any language of your preference. I'm a Python enjoyer, so here's an example of how you could write the algorithm in Python in 5 easy steps. First, let's define our function. Next, we're going to set our length and swapped variables. Third, we create our nested for loops, which iterate through our unsorted list. Fourth, we set our if condition that states if the two integers that we're comparing are unsorted, swap them. If a swap occurs, we set swapped to true. If nothing needed to be sorted in the current loop cycle, swapped would stay as false and we could break our loop. That's when we know our list is sorted and we can go ahead and return it to the console. Bubble sort is just one of many sorting algorithms, and it's one of the first that many programmers learn because it's straightforward. However, it does come with some downsides. Firstly, bubble sort has a worst case time complexity of big O n squared, which means that as the number of elements in the list increases, the number of operations required by the algorithm increases quadratically, as you can see on the graph to the right, which describes some of the different algorithm time complexities. This is because the algorithm needs to perform the length of the list minus 1 comparisons for the first loop cycle, the length of the list minus 2 comparisons for the second loop cycle, and so on until it performs 1 comparison in its final loop cycle. If you add up all the computations of each loop cycle, you get a time complexity of big O n squared. Now, this really doesn't matter too much for small unordered data, but as the size of your list increases, as does the time complexity at an exponential rate. Therefore, bubble sort is not recommended for large lists as it has a relatively slow performance with limited scalability. There are some better sorting algorithm options available out there for large data lists, such as merge sort, time sort, or heap sort. I hope you found this video interesting. Please let me know in the comments if you enjoyed this style of video, and I can make more like this for every single sorting algorithm I can find. Also, if you did enjoy the video, don't forget to like and subscribe. I'm a new channel and every bit of support I get is extremely motivating and helpful. Thanks for watching.